This is a key to topic 24, part A, worksheet 1. And on this worksheet, you were asked to find the zeros of these, and these functions here are quadratic functions. Now, so quadratic functions are easy to find the zeros for. The purpose of this worksheet is just for you to understand just what a zero is. All right, so a zero, when finding the zeros of a function, what you're asked to do is to determine where is, and I'm going to write it like this first, where is y equal to 0? That's what you're asked to do. So remember, in function notation, the notation f of x, g of x, h of x, f of x, and so on, that notation represents the y that we're talking about. And so if you want to find the zeros of a function, basically you are solving, you're setting this function equal to 0, and you're basically setting up an equation. You're finding where's this function equal to 0. Okay, so if we look at number 1, so number 1, we have f of x is equal to x squared minus 9x plus 8. And so if I want to find the zeros of this function, I'm going to set this function equal to 0. So this is the work. So you're going to say x squared minus 9x plus 8 equal 0. And you just solve this quadratic equation. Now this particular quadratic equation is factorable, so I'm going to go ahead and factor this. And so when I factor this, I'm going to get x minus 8 times x minus 1 equal 0. And then using the zero factor property, I get x minus 8 equals 0, x minus 1 equals 0. And so my zeros are 8 and x equal 1. So those are your zeros. All right, so the zeros are x equal 8, comma, x equal 1. Okay, so those two values here, those two values are the values of x for which this function is equal to 0. All right, number two, we have this quadratic function. It's g of x is equal to 7x squared minus 31x minus 20. Now, I'm going to go ahead and solve this one using the quadratic formula. So rather than determining if this function is factorable or not, I'm just going to use the quadratic formula because it is a quadratic equation. So to find the zeros, remember to find the zeros, basically what you're doing is you're setting this function equal to 0. So I get 7x squared minus 31x minus 20 equal 0. And then I'm going to go ahead and solve this quadratic equation using the quadratic formula. Now remember, the quadratic formula is this, the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. All right, and so in this case, a is 7, b is negative 31, and then c, your constant, is negative 20. So we get zeros are going to be x equal the opposite of b, which is going to be a positive 31. The opposite of negative 31 is a positive 31, plus or minus the square root of b, which is negative 31 squared. But remember, when I square this negative, it's going to be a positive, minus 4 times a, which is 7, times c, which is negative 20. All of that is being divided by 2 times a, and a is 7. Okay? Simplifying the radicand, I get 31 plus or minus the square root of, now negative 31 times itself, using a calculator, is going to be 961. All right, now in this part here, a negative times a positive times a negative will be a positive, so this is going to be 961 plus, and then multiply those three factors out, you get 28 times 20, which gives us 560. All right, all of that is being divided by 14. Okay, equal. And then 961 plus 560, so it's going to be 31 plus or minus the square root of, let's see, so when I add those two numbers, I get 1,521 divided by 14. Okay? All right, so that's a pretty big number in it. So let's first of all see if this is a perfect square. So I'm going to go ahead and I'm going to take the square root of 1,521, see if that is a perfect square. So square root, and then 1,521 equal, yep, 39. So 39 times itself is 1,521. So this becomes 31 plus or minus 39 divided by 14. So since the square root of 1,521 is a perfect square, the zeros are going to be rational numbers. So they're going to look something like this. They may not be a integer, but at least they will be rational zeros. Okay, so I'm just going to go ahead and do it this way. So I'm going to have 31 plus 39 divided by 14, and then 31 minus 39 divided by 14. And so 31 plus 39 will give us 70 divided by 14, which reduces to, let's see, they're both divisible by 7, right? So that's going to be 70 divided by 7 is 10. 14 divided by 7 is 2, which gives us 5. All right? So one of my zeros is 5. Over here, 31 minus 39 is a negative 8 divided by 14. And so when I reduce that, that's going to be a negative, what's that, 4/7? So those are your zeros. So the zeros are x equal 5 and negative 4/7. All right, so those are your zeros. All right, so that was number 2. All right, now in number 3, so let's take a look at number 3. In number 3, we have this quadratic. Remember, these are quadratic functions we're looking at. So number 3, we have this. We have h of x is equal to 7x squared plus 9x. Now, I'm going to go ahead and first of all, to find the zeros, you're going to set this function equal to 0. So you're going to find out where's this function equal to 0. So we're going to have 7x squared plus 9x equals 0. All right, so just remember, the 0, when finding the zeros, you're asking where is h of x equal to 0? That's what you're asking. So you're going to set this function equal to 0. Now, this quadratic function, or in this case now it's a quadratic equation. So this quadratic equation, I can find the zeros. I can solve this quadratic equation by just factoring. See, I can factor out an x here. So I'm going to go ahead and do it that way. So I get x times 7x plus 9 equals 0. And then using a zero factor property, I say each of those factors equals 0. So I get x to be 0, 7x plus 9 to equal 0. Now over here, I found one of my zeros. All right, x is by itself. Over here, I'm going to have to subtract 9 from both sides. So I get 7x equal negative 9. And then when I divide both sides by 7, my other 0 is negative 9/7. All right, so your zeros are x equals 0 and negative 9/7. Okay? All right, number 4. In number 4, we have this function. And so f of x equals 9x squared minus 25. And so now you should notice that this quadratic function, when I set that equal to 0, I can solve that by factoring because this is the difference of two squares. So let's go ahead and do it that way. So when I factor this, I'm going to get 3x minus 5 times 3x plus 5 equals 0. And then I just set each of those factors equal to 0 using the zero factor property. I'm going to get, so I end up with two linear equations. So one of my zeros is going to be 5/3 when I get x by itself. Over here, the other zero is going to be a negative 5/3. So those are zeros. So the zeros are x equal 5/3 and negative 5/3. Okay? All right, number 5. So let's look at number 5. So when we do number 5, we have g of x is equal to x squared minus 8. All right, x squared minus 8. Now, when I find the zeros of this function, I'm going to set that function equal to 0, like that. And so remember, in some of the other ones that we just did, it was factorable. Now, over the rationals, this is not factorable. So you may want to either use the quadratic formula, or you may notice, hey, there's no x term here. The x term is missing. So I can easily solve for x by using a square root property. So let's go ahead and do it that way. So what I'm going to do is, since there's no x term, I'm going to bring x to the other side. So I'm going to add 8 to both sides. So I get x squared equal 8. And then to get x by itself, I'm going to take the square root of both sides, just like this. Now, don't forget it plus or minus. And so the x and the x square, the square and the square root undo each other. So I get x equal plus or minus the square root of 8. Simplifying this, I'm going to get my zeros are plus or minus 2 square root of 2. So the zeros are x equal, now you can write it like this, plus or minus 2 square root of 2, or you can say x equal 2 square root of 2, and then negative 2 square root of 2. All right, so those are your zeros. Now I do want you to notice that these particular zeros are, these zeros are irrational. So those are irrational numbers, right? 2 square root of 2 is an irrational number. Whereas in the previous problems, and all these problems you've done, these zeros were rational numbers. So these zeros, I'm right here, zeros are rational. Zeros are rational zeros. Okay. All right. Now, so that was number 5. Now, let me go ahead and also do this one using the quadratic formula, just to remind you what you would do. So you could use the quadratic formula. So finding zeros using quadratic formula. All right, so let's go ahead and do it that way using quadratic formula. All right, just know that in this case, when I substitute values in the quadratic formula, a is 1, the coefficient of x squared. B is the coefficient of x. Since there's no x term, b is 0. And then c is your constant, which in this case is negative 8. So I get x equal the opposite of b. The opposite of 0 is still 0. Plus or minus the square root of 0 squared minus 4 times a is 1, times c, which is negative 8, right? All divided by 2 times 1, okay? All right, now, so simplifying the radicand, or in this case the discriminant, I get 0 plus or minus the square root of 0 squared is still 0. A negative 4 times 1 times a negative 8 is a positive 32, all divided by 2. Now, I'm going to go ahead and just remind you that 0 plus or minus this radical is plus or minus the radical. So I'm going to write like this now. So plus or minus the square root of 32, because 0 plus 32 is 32, divided by 2. Now, simplifying the square root of 32, remember the largest perfect square that goes into 32 is 16. So I can write the square root of 16 times the square root of 2. So that's 4 square root of 2. So this becomes plus or minus 4 square root of 2 divided by 2. Reducing, 4 divided by 2 is 2, right? Let me go ahead and write it like this just to show you. That's a 2 here. So 2 to 2 is 1, 2 to 4 is 2. All right, so this becomes plus or minus 2 square root of 2, and those are your zeros. Those are the same zeros you had if you went ahead and used the square root property. All right, so that was number 5. Okay, now number 6. So in number 6, we have this problem. So we have, and number 6 was the last one of our, the last one on our worksheet. So this number 6. So we have h of x is equal to x squared plus 16. All right, so we're going to find the zeros. And when I find the zeros, I'm going to set this function equal to 0 to find the zeros. And so notice here, though, that this is the sum of two squares. This is not factorable over the rational numbers. But just like one of the previous problems, I can, since the x term is missing, I can find the zeros by using the square root property. So I'm going to subtract 16 from both sides, and so I get x squared equal negative 16. And then taking the square root of both sides, don't forget plus and minus, I get x equal, so the square and the square root undo each other, so I get x equal plus and minus. Now remember, square root of negative 16, so remember the square root of a negative 1 is defined to be I, the imaginary unit I, so this becomes plus and minus for I. And so the zeros here are imaginary numbers. All right, so they're imaginary numbers. So these are imaginary zeros. Imaginary zeros. All right, sometimes we'll just say they're complex zeros. Okay, because of that I. All right, so those are your zeros. So you can write your zeros as zeros are x equal 4i, comma, x equal negative 4i. Okay? All right, so that was the key to worksheet topic 24, part A, worksheet 1. And again, the whole purpose of this, these were very simple. These were quadratic. The whole purpose of this was to get you in the idea of what a zero is and how to find the zeros. All right, so that's the end of this worksheet.